morning everyone. Our research topic is compare and conversion of Malayalam handwritten document to digitized document through various enhanced CNN models. Myself, understand.
Myself, Akshay.
We have reviewed almost 100 papers for our research. The first 50 papers will be summarized by me. In today's digital era, the digitizing regional handwritten documents like Malayalam is crucially for preserving cultural data and enabling easy search and storage. However, due to the complexity of Malayalam script, which includes common character and built handwritten skills, studying the data collection and preprocessing, most studies emphasize the importance of data set preparation. Researchers commonly use public data set, self-ordered data set, or other repositories such as vMinst or custom Malayalam character data set collected from native writers. Preprocessing techniques like binarization, normalization, noise removal, and segmentation were applied to enhance the quality of handwritten samples. Some studies also adopt data augmentation to handle classroom patterns and improve model generation. Next will be tell about the model architecture and techniques. The review covered several enhanced CNN architectures, models like LeNet, LeNet, VGNet, UNet, ResNet, and some of the layers of VGNet and ResNet as well. Were compared for the accuracy and efficiency of the related papers. Many papers proposed hybrid models that combine CNN with RNN and LSTMs to capture sequential dependence in Malayalam characters. Recent work introduced the attention-based CNN models and transfer learning techniques using pre-trained networking such as Inception V3, EfficientNet, which significantly improved the recognition of performance. The experimental techniques and evaluation. The performance were evaluated using metrics like accuracy, precision, effort score, recall. Most studies reported accuracy levels between 90 and 98%, depending on the dataset complexity, the number of datasets, and the pre-processing techniques. Optimization techniques such as ADAM and RSM prompts optimizers were frequently used to fine-tune models. Softwares such as TensorFlow, Keras, and PyTorch were commonly employed. The research gaps and the findings. The literature highlights strong progress in CNN-based handwritten recognition. However, several gaps remain. The lack of large diverse Malayalam dataset, limited exploration of real-world document noise, and multilingual tests. Need for lightweight, real-time models. For deployment on the mobile devices, our project aims to bridge these gaps by evaluating enhanced CNN models with improved pre-processing and feature extraction strategies. And the conclusion of the 50 papers. In summary, the literacy review reveals the CNN models have shown promising results in Malayalam handwritten text recognition. By comparing multiple architectures and identifying their limitations, our study set a foundation for developing and efficient models that can accurately convert Malayalam handwritten content into digital text. Thank you. The rest will be explained by my friend Akshay.
So the problem statement and objectives are the main problem identified in existing research is the low accuracy, inefficiency in recognizing Malayalam handwritten characters when compared to other languages. Most traditional OCR systems fail due to variations in writing styles and noise in scanned documents. These are the objectives of our review. To study the different CNN architecture used for Malayalam character recognition, to compare their performance in terms of accuracy and dataset size, and to identify the gap for future model improvements. Next is a methodology and research overview. For this review, we analyzed around 100 research papers published between 2018 and 2025 from IEEE, Springer, and other reputed sources. Each paper was examined for aspects such as the dataset used, model type, pre-processing methods, performance metrics, and software tools. Most studies used custom handwritten datasets collected from native speakers. Techniques such as image normalization, thresholding, and data augmentation were commonly applied before model training. Enhanced CNN variants like LeNet, LXNet, BGGNet, and hybrid CNN RNN models were frequently used to improve feature extraction. Next is our key findings and outcomes from these papers. The majority of studies reported recognition accuracies between 90% and 98% using deep CNN hybrid models that combine CNN with LSTM or GRU layers perform better for sequential data like word level recognition. Transfer learning and pre-trained models such as ResNet and LeNet also improved convergence, speed, and accuracy. However, one major challenge observed was the lack of large standardized Malayalam dataset, which limits the generalization of models. The research gap and future works. The gap identified include insufficient dataset covering diverse handwriting styles, limited exploration of attention-based and transformer models, inadequate real-time testing on noisy document image. Future research should focus on dataset standardization, model hybridization with transformers, and cloud-based deployment for real-time document conversion. To conclude the literature review, literature clearly shows that CNN-based models have significantly improved Malayalam handwritten document recognition, yet further research is needed to make the system more adaptable, scalable, and accessible for real-world applications. Thank you.